So we just did this problem. The notepad here is syncing up. But as we did this, we found out that we need a mu that is whose absolute value is less than 1. And, oh, here it is. So we found everything right here. And this is the mu that we need. Now, I want to show you why this works in CalcPlot. So let's take CalcPlot. Let's clear this stuff right here. And let me show you how to put this in CalcPlot. So I'm going to select right here vector field. Then what I'm going to do is I'm going to ask it to show the differential equations notation. Notice that I'm restricted in 2D because we're looking at plane autonomous systems. And I'm going to type in this stuff. So we got x plus y. X plus y. We also have mu. So we'll say negative m. And I think we have m here. So we'll use m. What about this one? Well, this one's going to be negative x plus m right here times y. And then once we have that, all we have to do is click on this and we can see something. Okay? Now, one thing that I would like to do is use a fixed length for all vectors so that the magnitude is not really showing, because right now we don't need it. And I think that's good. So now what we want to do is we want to get an m that is less than 1. And look at what happens. As m is less than 1, we start having this motion. And you can see the ellipse better, the cyclicity, I guess. I don't know if that's the word. You can see it better if you actually get more vectors. So let's say we get 15 vectors. Or let's say we get 20 vectors. No, 20 maybe that's too much. Let's do not 27. Let's do 17 vectors. So you get this, and now as this decreases, look at what happens. We get a nice circular motion right here. And why is this cool? Well, I don't know, because this could be modeling something that shows a relationship between these two dependent variables with respect to time that goes like this. Like, for example, population of rabbits and of predators of the rabbits, like foxes. So that's why this is super powerful. And look, as we become negative, what happens? We get back to where we started in the other direction. And then this becomes a saddle. So isn't that pretty cool? I think this is super cool. I hope this was useful. You can even press animate and it'll show you all these things for you. And this is like, let me tell you what this is. This right here, let me put it back. This is the trajectory that we would get at this point. So that 0, 0 is a center. So if this is a center, then nothing should move right here. And you see how if I click here, there is no trajectory, but anywhere else there is a trajectory. Look, and all the trajectories are around that 0, 0. And if I animate it, it'll show you how the trajectory changes based on the value of mu. I don't know about you, but I think this is super cool, and this is a very useful tool to have. All right, this was it for this video, and I'll see you next time.